Karen wants to advertise how many chocolate chips are in each Big Chip cookie at her bakery. She randomly selects a sample of 76 cookies and finds that the number of chocolate chips per cookie in the sample has a mean of 13.7 and a standard deviation of 3.6. What is the 80% confidence interval for the number of chocolate chips per cookie for Big Chip cookies? Enter your answers accurate to 1 decimal place because the sample statistics are reported accurate to 1 decimal. Okay, so let's dig through and find out what we are supposed to do here and work from there. All right, so the question is, what is the 80% confidence interval for the number of chocolate chips per cookie for the Big Chip cookies? Yeah, that's what they're called. Okay. All right, so constructing a confidence interval. So confidence intervals, they have a point estimate, which in this case would be the mean, and we add and subtract a margin of error. So we have some information given to us from the problem. Let's dig through there. We have a sample of 76 cookies, and the number of chocolate chips per cookie in the sample has a mean of 13.7, a standard deviation of 3.6. So let's write that information down. So we have a sample mean of 13.7, a standard deviation of 3.6, and a sample size of 76. Now, what we need to do is come up with the confidence interval. Now, there are 2 different ways of effectively doing this. One is strictly using the calculator, and the other is using some formulas. So let me show you how the calculator works first, and then if you need the formula explanation, continue watching after that. So when using the calculator, you have a few different functions that will help you come up with confidence intervals. The ones that deal with sample means are z-interval and t-interval. And often you have to make a choice as to which one you're going to use. You would use z-interval in the case that you happen to know the value of the population standard deviation. But that's a pretty rare situation. So for the most part, you're going to use t-interval. So that's a distribution that you can use that's very similar to the normal distribution, but allows for the use of a sample standard deviation, which if you'll notice, I labeled my standard deviation as S because this is from a sample of cookies. So I'm going to use t-interval, and I'm going to set to stats and then input the different values. So 13.7, S is 3.6, N is 76, level of confidence that was given in the problem as 0.8. Then we calculate. Oh, and to be certain here, it is safe to use a t distribution. We weren't told that the original distribution was normal, but we do have a sample size that's large enough. The cutoff for the central limit theorem is 30. So we have a sample that's bigger than 30, so we can assume that the sampling distribution would be normal. So we're safe to use the t distribution. And if we hit calculate, we come up with the endpoints of our confidence interval. So 13.2 and 14.2. And that's all you would need to do if you were using the calculator. Now, if you're using formulas, follow along. Otherwise, you can go ahead and move on to the next problem. So to use formulas, we need to calculate the margin of error. And the margin of error has a formula which is t sub c times s divided by the square root of n. And t sub c is a critical value based off of a t distribution. So we use the inverse norm, inverse t function of the value 1 minus the level of confidence divided by 2. The only difference in the t distribution and the normal in terms of input is the second input is a number of degrees of freedom. And the number of degrees of freedom is just one less than your sample size. So here we would do the absolute value of the inverse t. The level of confidence is 80%, so 1 minus 0.8. That's 0.2. And we divide by 2, so that's 0.1. So 0.1. Then the degrees of freedom is just one less than your sample size, so 75. And if your calculator has inverse t, then hit second in distributions and you'll see it in the list. If not, then you really can't go any further. You have to have something to find inverse t values here. The area is 0.1. The degrees of freedom is 0.75. Paste that, press enter. So 1.293. So my margin of error then would be 1.293 times the standard deviation of 3.6 over the square root of 76. And I think what I'll do is I'll just say times, just to make sure I get it just as accurate as I can. 3.6 divided by the square root of 76. And I realize this is going to come up negative, but I didn't, when I used the negative 1.293, that negative is still there. So this is supposed to, the margin of error is supposed to be a positive number. So I'll just take the absolute value. So 0.53. And effectively, what I would do then is take the sample mean, 13.7, minus that margin of error that I just came up with, and 13.7 plus that margin of error. Whoops, sorry, 13.7 plus 0.53, not 5.3. All right, so I have 13.17 and 14.2, which round to the same endpoints. So 13.2 and 14.2.